Okay, so we're going to work on solving polynomial inequalities, and in order to get where we need to go with this, we're going to try to factor this polynomial here. Now the first step, and the easiest thing, would be to actually common factor our value of 2 out. Since all of these are even numbers, we're going to take out a value of 2, and specifically maybe even -2, just so when we do go to the factoring everything, we're working with our positive values. So when we go to factor this out, the idea is that we're going to divide each of these values by -2. So our -2 becomes outside of the brackets, and we're left with positive x cubed plus 3x minus 6x minus 8. Okay. From there, we're going to look at our bracket specifically. So when trying to find a factor, one of the ways that's very helpful is looking for factors of the last term to see if any of those create a 0 within these. Okay, so we might have to try it out. My calculator on here is not so great, so maybe we'll get you a calculator on the side. And we're going to try some factors of this value. Quickly, 1. Oh, and that should be squared. Okay, put a square there. Okay, 1 will give us, no, not a high enough number. So let's try with 2. 2 will give us 8, 4. Yes, 2 will work great. So if you put it in, I'll quickly do it on the side. Thanks, Steph. We'll get 2 cubed plus 3 squared. I'm kind of running out of room. And then minus 8. 2 cubed becomes 8. So we have positive 8 and negative 8. So they will cancel each other out. So we're then left with 3 times 4 minus 6 times 2, which both create 12s. So they cancel out. So 2 is a factor of this. So whether we're going to solve it synthetically or through long division, we'll probably use synthetic division. I'm going to show you the other way, actually, that we go about doing this. For this synthetic division, I'm actually going to use addition when going down. Okay, and the reason I'm going to do addition is I'm actually going to use the x-intercept of 2. So instead of using, because this is 2, normally we would write it as x minus 2 if we're going to do our long division. But because that means x is equal to 2, I'm going to take the value of 2 and then put our polynomials here. So we have 1, 3, -6, and -8. So we bring down our first term, which is 1, and then we need to multiply it by our value here. So we multiply by 2, and we end up with 2. So we're going to add these now. So 3 plus 2 gives us 5. Multiply by 2 again, we end up with 10. -6 plus 10 will give us our 4, and 4 times 2 gives us 8, which gives our remainder of 0. Okay, so when we factor this all out, and is that okay, the addition? That makes sense? Okay. So when we go to factor this all out, we still have our inequality. 0 is greater than and equal to. X minus 2 is kind of one of our brackets. And on our polynomial, we're left with x squared plus 5x plus 4. Now this one is a quadratic. So we can actually use, and because it has a value of 1 here, we can use some very simple factoring. We need 2 numbers that add to 5 and multiply to positive 4, which are actually 4 and 1. Okay. Are you okay with quadratic factoring? Okay. So we'll kind of go through this the fast way then, which means that these are going to work out into factors of x plus 4 and x plus 1. Okay. So we've now factored this. Now, sorry, I forgot to write this in. We still have the factor of -2 here. So we have our -2 factor, and this value is actually important here because we need values, and we're going to split this up just like if we were finding x-intercepts. We're going to split this, and in this case, we're going to split it into 3 separate equations here. Okay, and we need to find values that will essentially give us values that are less than 0 when we go to plug them in. Okay, so we're going to set this up, and I'm going to attach this -2 to one of the factors. Okay, technically it doesn't matter which of the factors we attach to, so I'm going to attach it to this factor because it is technically part of this. So we have 0 is greater than or equal to -2 x minus 2. We have 0 is greater than or equal to x plus 4. And 0 is greater than or equal to, I'm going to get her. We're splitting them up, and the last one is 0 is greater than or equal to x plus 1. But I guess instead of solving them as inequalities, know that these are going to be actual intercepts, right? Because we've just factored this polynomial. And so what we'll do is we'll place them as intercepts. So essentially we'll set them equal to 0, okay? Instead of the way the inequality is set it up. So we'll do those in purple because it is a little different. 0 is equal to our, and we could have actually in this case eliminated the -2 here. So this is negative 2. We could have divided this entire equation by negative 2, and it would have came out as 0 again. So this would be x minus 2. 0 is equal to x plus 4. And 0 is equal to x plus 1, which means our points are at x when it's 2, x at negative 4, and x at negative 1. So these being critical points, we use them kind of like on a number line. We use them to test values. So our 3 points are at negative 4, negative 1, and 2. And I kind of just drew those in arbitrarily. Let's say this is 0 and 1. Right, so here's 0, here's 1. That worked out good. 2, 3. Oh, I almost did it perfect. 4. Okay, so 4 over a little. Okay, so these being important points to us, what we're going to do is test for values to the left of negative 4, a value between negative 1 and negative 4, a value between negative 1 and 2, and then to the right of 2. So we can pick arbitrary numbers to plug into the polynomial. Okay, so for instance, something greater than negative 4 is negative 5. And usually try to use numbers that we might be pretty good with working with. Negative 2 falls in here. 2 is usually an easy value to work with. 0's in here. That's always nice to work with. And let's use positive 5 again. Okay, so these will be our 4 arbitrary values. What we're going to do is we're going to break these up into specific points. So have they done it this way here? When x is less than 4. At negative 4, okay, because it is an inequality. We have to choose those actual values too. We're going to break them all up to see essentially where the polynomial is positive and negative. So this idea, we're going to make kind of a chart here. And because it's an inequality, they did make a good point there. We do need to actually test because it can be equal to these zeros also, right? Negative 1 and 2. So we're looking at 1, 2, 3, 4, 5, 6, 7 points here. What we do is we break our factored form. So here's our factored form here. We'll break it into points to figure out whether we're positive or negative at specific areas. So we know we have negative 2 is a value, which is always going to stay. We have x minus 2 is 1. Another one is x plus 4. And finally, we have x plus 1. So, for instance, for our first value of negative 5, if we were to plug negative 5 into this factored form, what we're going to do is set up a chart to see essentially what would we be. Would we be positive or would we be negative at this point? Well, negative 2 stays at negative 2. So no matter what, it's a negative term, right? So this will be negative. When I plug negative 5 into this part of the equation, negative 5 minus 2, we're negative again. Okay, so the idea is we're multiplying to either find a total negative or positive value. When I plug negative 5 into here, we're negative. And when we plug negative 5 into here, we're negative. So if we were to multiply this entire column, okay, so we multiply everything down here, what would our final term be in this case? Would it be a positive value or a negative value?
Positive.
That's right. So in the end, we end up with a positive value when at negative 5. Okay. So then we can, again, test our other values. And actually, I think I want to go in between, because normally we test in between. I'm gonna look back at the inequality. We're going to choose our in-between points. At negative 2, which is also an in-between point, we do the same thing. Well, this will also stay negative. It doesn't change, right? Our first term is always going to be negative here. At our second one, we're going to have a negative value again. Here we'll have a positive value. Does this make sense?
Okay.
Yeah. And here we'll have a negative value. So what will we end up with in the end here?
Negative.
A negative. So at this point, in between that interval, okay, so this is when we're to the left of negative 4. This is between negative 4 and negative 1. We're negative at that point. Between negative 1 and 2, is it? I think. Yeah, I think 2 is our other point. We said we're going to take the value of 0. So we'll use 0 in here, and here we're going to use 5 to figure out what we are at this point. So, at these points, again, this will be negative, this will be negative. When we do 0 here, we're negative. 0 here, we're positive. And 0 here, we're positive, which means what are we going to get?
Positive.
A positive value. That's great. And finally, the last one, when we have 5, we are positive, positive, and positive, which means we have a
Negative.
negative answer. Okay. So we're clearly changing every time. And have they talked about when it's going to be 0? Yeah. Those zeros are essentially going to give us a value of 0. Okay, that's when we're crossing over with our inequality. So this helps with graphing also. This gives us the idea that our inequality, okay, when graphing, if we have our point at -4, point at -1, and 2, and if this is our kind of our y-axis, we know that this polynomial is positive to the left of -4. So in other words, it's above the x-axis, and that's what we're talking about. So it's above the x-axis at -4. It's negative in between. It's positive again. So we'll talk about negative here, positive here. It's positive, and then after -2, it's negative again the entire way. So it gives us an idea when graphing. So they were looking for when this polynomial is essentially less than and equal to 0. That's what the original equation was. When is it less than and equal to 0? So let's go to our little graph at the bottom here. Okay. Well, we know between -4 and -1, it is less than 0. Okay. It is also equal to 0 at -4 and -1. So that's an important part. And it is also equal to 0 at 2 and less than 0 when greater than -2. Okay. So say you're to kind of write a domain to this answer. Oops. In this case, x is, or our polynomial f at x. Okay, so f at x is less than and equal to 0 at these points. And that would be when x is less than and equal to -4, because it is 0 there, and -1. That's not right. And when it's less than and equal to -1. And when x is greater than and equal to the value of 2. So these are our answers. It's a whole range of answers in this case because of the inequality here.